Okay, so for each of these questions, hopefully I'm going to try and timestamp them in the comments below. So from question 1 through to question 10. I'm not going to spend too much time going through each of them. I'll try and do several in different ways, but that aside, I'm going to try and do them as fast as possible, just so we can see how to do them. So for 1A, I will explain obviously a little bit as I go on my thoughts, but it's more just how I'd answer these. So the first thing is, as I'm writing this down, I'm just looking at the power. The top power is what I want to do. So I want to cube this. The bottom power is a root. So I want to do the 5th root. I generally will start by doing the 5th root because it makes the number inside smaller before I then make it bigger. So I'm going to do the 5th root of 32, which is 2. 2 cubed is then 8. So that's question 1A. In B, same idea. Apart from I'm looking, in this particular one, I'm looking for that negative. So it is actually a negative a half there. It looks a bit blurry. That negative means take the reciprocal or flip the fraction upside down. So you're going to do 1 divided by the fraction, which effectively does this. Now, please keep note that that x is on the bottom. And then that half is, I'm just going to multiply each of the powers. So this 4 is 4 to 1. So that's going to become 4 to the half. And remember, a half is actually a square root. So I'm actually just going to go through and square root each of these. So square root of 4 is 2. Square root of 25 is 5. And the square root of x to the 4 is x squared. Don't forget it acts on each of these. It's not just the 25 or the x. It's going to act on both of those. You're doing the square root of the entire thing. So that's question 1. Question 2, a couple of ways of doing this one. I'm going to do the one that stands out to me straight away, which is just to jump straight in. So if you jump straight in, the idea behind this is you want to times top and bottom by the conjugate. And the conjugate it's what basically gives us a difference of 2 squares in the bottom. So notice it's minus here. So I'm doing a plus here because when I times these together, remember these implied brackets around top and bottoms of these fractions. When I times these two together, it gives me a difference of 2 squared. So root 12 times root 12 gives me 12. And root 8 times root 8 gives me, remember this is negative, so it's going to give me a minus 8. Big thing here is I don't get any of the cross multiplications because root 12 times root 8 is going to cancel with minus root 8 times 12 times root 12. So they're going to cancel out. So that's the idea there. 2 times root 12 is 2 root 12, and 2 times root 8 is 2 root 8. Next step here is to simplify as much as possible. So here we get 2 root 12 plus 2 root 8 over 4, divided through by 2. I'm not going to do that right now, and you'll see why in a second. Root 12 and root 8 both simplify. Root 12 is the same as 2 root 3. And root 8 is 2 root 2. So I'm just replacing each of those. So this in the bracket there, and this one in the bracket, that's my root 12, and that's my root 8. All that's divided by 4. Now 2 times 2 is 4. 2 times 2 here is also 4. So these are going to cancel with this one, giving me just root 3 plus root 2. Now that takes a lot longer than if you were just to simplify in the first place. So starting with root 12 minus root 8, you can actually simplify this straight up. So if you do the root 12 is 2 root 3 minus 2 root 2, you can simplify this to be 1 over root 3 minus root 2. Now when you times that by the conjugate, you get root 3 plus root 2, and then again at the bottom there, I'm going to times by that same thing. So when you actually times this together, 1 times the top is just root 3 plus root 2. And then at the bottom here, you get 3 minus 2, which is just 1. So when you work that out, you actually get this same thing. So that's question 2. Question 3, finding sets of values. I'm going to bring my calculator in for a lot of this. You can do it legitimately. I'll talk about that as well. But the calculator should be your friend for this question. So the first one is not calculator, unfortunately, to start with. You need to expand and rearrange. We want to get one of the sides equal to 0 first. So expanding this bit, we get 3x minus 6 is less than 8 minus 2x. So I've just expanded that bracket there. Taking everything to the left, you get 5x and then the 8's coming over, so that's going to be a minus 14 is less than 0. If at this stage you want to, I believe, let's just double check. I can't remember on the calculator if it can do simple ones. Now, so the calculator can only do 2 to 4. It basically expects that you can do the rest on your own. So I'm going to solve this myself. So I get 5x is less than 14. So at this point, I should have actually taken the 6 across here. So the negative 6 should have joined the 8. So I should have written this step here instead. Dividing through, I get x is less than 14 over 5, or 2.8. There are ways to solve equations like this. So if it wasn't a less than, I can put that back in a second. But on my calculator, I can actually code this on here. So if I put in something that looks like this, and then using this alpha button, I can press this equals here above the calc, and then 8 minus 2x. And then if I use shift and next to that equals button is this word solve. If I press solve and just, this is basically just saying where do you want x to start. It doesn't really matter for you in this point, but certain questions, because this solves it in a iteration kind of process, it does matter where you start. But don't worry about that for now. I'm just going to press equals, and it tells me here 2.8. So it'll tell me a little bit going on there. It's an interesting one to actually, if you can want to solve equations that way. It can do it for quadratics as well. It won't tell you both roots straight away though. Anyway, part A is x is less than 2.8. Part B, I am going to use a calculator. So the first thing you want to do is to expand that. So 2x times x is 2x squared. And we've got a minus 7x and a plus 2x. That's going to be a minus 5x. And then we've got a minus 7. And that's less than 0. This one you can put straight into the calculator. So if I go down to the bit that's got the inequality on here, just this bit. And it's a degree 2 because it's a quadratic. And it's less than 0. So it's option 2. Putting in my coefficients there. And then just hitting equals. It tells me it's between minus 1 and 7 over 2. How do you actually do it? Well, you want to sketch this graph. We know it's a positive. And if you were to actually solve the roots for this and factorize it, you can see from the very first part of this question, we already know that the roots are going to be x equals minus 1 or 7 over 2, simply because it's already factorized for us. So I know it's minus 1 and 7 over 2. So you're actually, in the initial question, you're given everything you need here. Expanding this might have actually been harder than being able to solve this straight away. So we've got minus 1 over here and 7 over 2. We want to know when it's less than 0. Less than 0 means below the x-axis. Greater than 0 is above. Equal to 0. Equal to 0 is when we solve it. So we do that all the time. So greater than 0 above the x-axis, less than 0 below the x-axis. So the curve where it's below is from here. So it's this jaggedy line to here. So you can see it's between the two roots, hence this style of writing it. If it was greater than 0, it would be bigger than 7 over 2, because that's the x numbers this way. But minus 1, it's actually x numbers this way that we want. So that's less than minus 1. So that's if it was greater than 0. So you've got to be careful what you're looking for there. So my actual answer, though, is minus 1 is, x is bigger than minus 1, but less than 7 over 2. C, I want to know when it's both of these things now. So I'm looking at the two solutions I've got for each, and I want to know when it's true for both. Keep in mind, this one here is between minus 1 and 3.5. This one is saying it needs to be less than 2.8. So to combine that together, we can't go all the way up to 3.5 because the maximum on this one can be 2.8. So we want it to be from minus 1 up to 2.8 because we can't go beyond 2.8 or 14 over 5 up to this 3.5 because this inequality doesn't allow it. So we're just looking for where these are. So in effect, you could think about drawing this on a number line if you wanted. Here's minus 1. Here is my 14 over 5. And here is my 7 over 2. So my joint inequality here is from this kind of this open circle down to here. So these open circles just represent like it's a strict inequality. And then less than 14 over 5 is this bit taking us all the way that way. So when we combine these, we can see we can't go below this one and we can't go above this one. So it's between these two things, which is what I've just written here. That's question 3. Question 4, the mark X scored by each student who sat a statistics examination is coded using this particular function, y equals 1.4x minus 20. The coded marks have mean 60.8 and standard deviation 6.60. Find the mean and standard deviation. First thing to note here is the mean is affected by both this multiplication and this kind of add-on minus 20. The standard deviation, it doesn't matter whether you move all of your data up by 20, down by 20. The standard deviation will stay the same. The standard deviation is measuring kind of the spread of these numbers. So if you transpose or translate those numbers anywhere by the same amount, the standard deviation of those numbers themselves are only differing by the same amount. So it doesn't matter about this minus 20. The standard deviation is only affected by this 1.4. We've been given the coded marks. We want to work backwards. So in other words, we want to do the reverse of this. So to go from, let's call the coded mark X, to go from the coded marks, which are X, to our little things, what we're going to want to do is we're going to want to add 20 and then divide by 1.4. Now, I wouldn't really write it out like this, but this is for the mean. So that's to get me to little x. So I'm just unwinding this. Let me just rub that out. So how would I actually want to go and put this down? Let's just get my pen back. I know that if I start with 60.8, then, so if I've got 1.4x minus 20, then I get my 60.8. Now, because I'm talking about the mean, I'm actually going to update this to the mean. There we go. And I just want to unwind that. So the mean is actually equal to 80.8 divided by 1.4, which is 57.17 or something, if I remember rightly. So let's just go all the way back. 80.8 divided by 1.4. Yeah, 50 I've got these the wrong way around. It's 50.71. And that's fine. For the standard deviation now, because it's not affected by this minus 20, we just know that 1.4 times the standard deviation is equal to 6.6. So the standard deviation is 6.6 over 1.4, which I don't want to try and remember this one. I think it's 4.7, but yeah, 4.71. There we go. So there's those two marks. So just remembering the big thing there is that the standard deviation is not affected by that minus 20. It's going to remain the same. Question 5, factor theorem. We use factor theorem to show that x minus 3 is a factor of f of x. This is a substitution, not a long division or anything like that. So we just want to simply do, if x minus 3 is a factor, then f of 3 should give us 0. So that's the idea there. So I just want to put 3 into this. So f of 3 is equal to 4 times 3 cubed minus 12 times 3 squared plus 2 times 3 minus 6. I just want to work that out. So this is 3 cubed is 27 times by 4 is 108. Obviously use your calculator for this. 3 squared is 9. 9 times 12 is 108 as well. Well, yeah. Cancels out, that's nice. Plus 2 times 3 is 6, minus 6. Oh, it cancels out as well, so it's all 0. Sorry, just double checking and second guess myself there. Part B, hence show that 3 is the only real root of this equation. Obviously, when we're finding roots, we want to factorize. It says show that, not use your calculator to show that. So I'm going to do it properly. I don't want to see things happen on calculators, and then I don't, like, your examiner doesn't want to see you just going, oh yeah, my calculator said this. So therefore, that's it, it's done, I've shown it. I want you to show it, show me what you know. So hence show that 3 is the only real root. I want you to factorize it. So we know that x minus 3 is a factor. We also know if we do a long division of these things, we can find the other factors. So you can do the long division like this. So x into 4x cubed is 4x squared and multiply up and such. So I'm going to do this quickly, or at least as quickly as I can, which is not too quick. So these cancel out, which is nice. So that just leaves me with 2x come down. X into 2x is a 2. and then times it through here, I get a 2x and then a -6. Technically, I should bring that -6 down 2, just for when I subtract. 2x minus 2x is nothing. -6 minus -6 is also nothing. This is a great long division there, really quick. So this means that x minus 3, so f of x, can be written as x minus 3 times by 4x squared plus 2. And now for this to only have 3 as a real root, we need to show that 4x squared plus 2 has no roots. So let's see what happens when that's equal to 0. So if you solve this, you get down to x squared equals 1 over 2. So, sorry, minus 1 over 2. So take the 2 across and divide by 4. You can't square root a negative and get a real answer. So that's what we're looking for here. So x equals plus minus the root of -1/2, which is not real. So that would give us imaginary roots. So therefore, that implies that 3 is the only real root. And just again, I'll show you the synthetic division of this, just in case anyone is trying to learn that. So if it's x minus 3 is a factor, you put the actual root there, which is 3 on the outside. And inside the little box, you put the coefficients at the top. So 4x cubed minus 12x squared plus 2x and then -6. This last column here will contain our remainder. Everything else is the coefficients. This was x cubed. What's underneath will become our x squared. So what we do is we write that down first of all, and then we do 3 times 4, which is 12. And then you add these coefficients together, or these numbers. So -12 plus 12 is nothing. 3 times 0 is 0. And then you add these together. 2 plus 0 is 2. 3 times 2 is 6, and then you add these two together. -6 plus 6 is nothing. So this represents your constant, your x squared. So this is 2, and then plus this is my 4x squared. So that's my actual remainder. Not my remainder, sorry, my quotient part. So this is the quotient part, this bit's the remainder, which we expect to be 0. And that's it, so that's synthetic division. There's question 5. Question 6, old calculator. So I'm going to bring in my old calc here. You can actually do this question in a matter of seconds if you understand what's being asked here. So the probability of a bolt being faulty is 0.3. So it can either be faulty or not faulty. Straight away, it's jumping out to me that x is a binomial distribution. So, and there's 20 in a pack. So we've got 20. Probability of being faulty is 0.3. Part A wants me to do exactly 2. So exactly means an equals. And part B wants me to do more than 3. So probability that x is greater than 3. Now, please keep in mind on your calculator when you go into it, it's not that smart. So you need to know what you're doing with it. The PD one is when it's equal to. The CD one is when you've got inequalities. But when you're using the inequalities, I'll say in a second, the calculator only does a certain type. So number 4, certain calculators don't, but this one does. So when I go into my number 7 and I go into number 4, please make sure you choose variable, not list. List can be handy, but not for this one. So x is 2, my number is 20, and my probability of success is 0.3. And there's my answer. So I've got 0.0278. So I like to do 4 decimal places. For greater than 3, though, when we go into that, when you put your number in here, your calculator can only do less than or equal to. It can't do greater than. So if we want the probability to be bigger than 3, it means we don't want to include 0, 1, or 2. So we want everything else. So we're going to take everything and we're going to remove the ones we don't want, which is 0, 1, and 2. So we're going to remove everything less than or equal. Oh, sorry, I don't want 3 either because it's a strict one. Apologies. So that should be a 3 there. So I don't want 0, 1, 2, or 3. So when I put that in, I need to do that subtraction. So again, I'm in CD and my X value here is 3. Press equals, and it gives me this number. So then I need to do the actual subtraction. So 1 minus 0.1070. Now to do this quickly, you basically want all the digits to add up to be 9. So 1 minus, I get 0. So 1 plus 8 is 9. 0 plus 8, 0 plus 9 is 9. 7 plus 2 is 9. And this last one, 0 plus 9 is 9. So that's kind of the bit. And then we got dot, 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 because this was dot, dot, dot. So it's 0.8929. As I say, all these digits just add up to be 9 to give us the kind of subtraction there if you want to do it quickly in your head. That side, number C, or part C, is definitely the hardest bit. So in part C, we've got the bolts are sold in bags of 20. John buys 10 bags. Find the probability that exactly 6 of these bags contain more than 3 bolts. Now, the big thing here is this bit just connects it to the first part, or the first bit of the question. The bolts are sold in bags of 20. That connects it to up here. We know that the probability of more than 3 bolts from this samples of 20, this is the probability for that. So in part B, we actually calculate the probability. We're now taking 10 bags and we're wanting to find out the chance of 6 of these bags containing more than 3 bolts. This, let's just call this Y for now. So Y is a new variable, not X this time. I've changed it to Y. And we're going to model this binomially from 10 bags because John's purchasing 10. The chance of him actually getting a faulty bag, we calculated in part B, is 0.8929. So we're actually recreating a different binomial distribution where Y is, of course, this time is the probability of getting a bag with more than 3 bolts. So this probability is the probability of getting more than 3 bolts from a bag. That bag contains 20 bolts, and we worked out the faults in part B. So this is the way to answer this. And then we're wanting to find the probability that Y is exactly 6. So it's the same idea. We need a PD, but this time we're just updating these variables. So we've got X is 6. It's actually our Y because we renamed it. N is 10. And the probability is 0.8929. So we've got 0.014. 0.014, and I'm going to stick to 0 just as I say I like 4 decimal places. So that's how you do question 6. If you spot that quickly, it's all calculated and very quick, and you can do a lot of the kind of simple calculations in your head just to simplify. Again, use your calculator just to double check if needed. Number 7. Number 7 is tedious. Number 7 is a lot of work on the calculator. There's a little bit of work that goes on in the question itself. So the following table summarizes times to the nearest minute recorded for a group of students to complete an exam. Estimate the mean and standard deviation. So we're looking for an estimate because these are grouped, but please keep in mind when you look at these groups that they're a bit broken, 11 to 20, 21 to 25. So what if I took more than 20 minutes but less than 21? Which category do I go in? So we've got some kind of rounding. So I'm just going to take this bound here, for example, the 11 to 20. It's not actually 11 to 20. It's going to be 10.5 is less than X, less than or equal to 20.5. So it goes all the way from 10.5 up to 20.5. The class width here is 10, whereas it looks like it's 9 originally. So you need to be very careful on that. The midpoint of this class, again, we need to actually consider that. So we're looking at the midpoints of these classes here. And the midpoint of this one is going to be 15.5. So because the class width is 10, half of that is 5, added to the bottom bound gives me 15.5. So I'm actually going to list these above here. These are the midpoints. Let's just call that midpoint. The midpoint of this one is going to be 23. And the reason for that is this is 20.5 less than X, less than or equal to 25.5. So the class width is 5, half it is 2.5, 20.5 plus 2.5 is 23. So the other way to do it is simply just add the lower bound to the upper bound and take the average. So we got 23. So there's a few different ways of doing that. So I'm just going to calculate each of these and put them in as we go across. So I've got 28. This one here is going to be 33, 40.5, and lastly 53 by the looks of it. So yeah, it's 15 wide, 17.5, and the low bound's 45.5. Yeah, so 53. With these numbers, you're going to use your calculator to estimate the mean. So you're going to use, these are the frequencies, I suppose, we're going to do, and the number of students that, sorry, these are the X values we're going to use, and the frequency is the 62 and such. So in calculator, I'm going to go down to statistics, and I want a one variable statistic, so option 1. Notice here I've got this frequency column. If you don't have that, so your calculator might come, let me just find that for now, and then I'll show you how to actually turn it on and off. Your calculator might show like this. If that's the case, you press Shift, Menu, and it's not these first 4, you need to scroll down 1, and you need to click on number 3, statistics. It'll say, do you want your frequency on or off? I leave it on at all times, because on these calculators, when you put in my 15.5, for example, it automatically generates a frequency of 1 anyway. So what I want to do is I'm just going to put these in, and then I'll update the frequencies afterwards. So I put all in all my X values, and then I'll check those as I go back up. But then I can go up the frequency column and I can update these. So I'm going to do 62, 88, 16, 13, 11, and 10. So putting those in, and then I want to click on the bit that says option. This option allows me then to carry out my different statistical calculations. So I click on option. I want the one variable calculation, number 3. And then it's telling me a lot kind of going on with these statistics that I've just entered. And this is actually part A finished now. So I've got 5 points just for working out these midpoints really, and then pushing buttons on a calculator. So the mean, which we call X bar, is 24.1875. And the standard deviation, which is the little cannon, is 9.29. Now you can use the formulas to work these out. I just say do it the easiest way, which is using the calculator. Part B is using linear interpolation. So if you are using the formula, just remember the formula itself for this kind of set of data, you would do the sum of ft squared divided by, and then it'd be the sum of frequency minus the sum of ft over the sum of frequency, but then this is all squared. So this is effectively the mean squared. So this is the square of kind of, well, whatever this thing is here, divided by frequency minus, and then it's the square of the mean. So that's the formula for standard deviation. So if you are going to use that, it's absolutely fine. And then this bit here is the mean. So I'm not going to write them out separate, but you can use those formulas if you wish. You are given one of these. It's just much easier to whack in the calculator. Use linear interpolation to estimate the value of the median. Keep in mind the median happens in the middle. If you add up these frequencies, you actually get 200. Really important. So we know the median is going to happen at the 100th value right in the middle. The 100th value occurs in this category here. So there's 62 up to this point. After that, there's 88. So up at this point here, there's been 150 values. So obviously that's a lot of values in these first 2 categories. But we want the 100th, which is somewhere in this one. So the way that I do this, and there are different ways of going about this, but I look at, we're up at 62, how many more until I get to the 100? So we're at 62 already. I want to go into this category, this 88. I want to go into there by 38 out of a possible 88, because 38 plus this 62 is 100. Now, I'm going to multiply that by the width of this category, so the time itself. So to get from 21 to 25, what is that class width? Now, if you use the proper bounds we spoke about up here, that class width is actually 5, because it goes from 20.5 to 25.5. I'm going to times that by 5. So that's the first little bit. But then I remember I'm not starting at 0, so I need to add to it the lower bound of this category that I started in. So that's 20.5. And that should tell me my answer. So that's how I do interpolation. Now, that's a combination of different kind of methods, but there are some other kind of ways of doing that. I just do it as proportion. So I want to go proportion. I want to go 38 over 88 into my 5 width category. That tells me that I want to go two kind of minutes into that category, but the category itself started at 20.5. So I need to add that correction in. So I get 22.659 or 22.66. So that's part B. Part C actually helps. If you get part B wrong, this part C might help you to figure out your calculation, because you want the lower quartile. So that's going to be the 50th value. that takes place in this first category. So I want the 50th value out of a possible 62. The category itself is 10 wide and it starts at 10.5. So if I put that in my calculator, 50 out of 62 times 10, and then I want to add that to 10.5. Could do all that in one line, but I get 18.6, which is what they're looking for. So if I got that wrong though, I know to go back and double check part B. So that massively helps. In D, estimate the interquartile range. Now, the interquartile range, we need the upper quartile and the lower quartile. We've just found the lower quartile or been told it, so we just need to find the upper quartile. I've actually already spoken about the upper quartile. The upper quartile would happen at 150th value, so we've got 200. The upper quartile is 3/4 of that, which is the 150th value. 150th value, we said actually happens right on this boundary. So 62 plus 88 is 150. So this boundary is 25.5. So Q3 would be 25.5. You can calculate that in other ways, but you might as well use logic. So we've got 25.5 minus 18.6, which was the lower. Don't want to include the median here. And that's 6.9. So that's the interquartile range. E, give a reason why the mean and standard deviation are not the most appropriate summary statistics to use with this data. Well, the idea of the mean and standard deviation is when you've got a well-distributed data set, which this clearly isn't. If you were to have a look at this data set, it's very much bottom end heavy, or negatively or positively skewed, whichever one you want to kind of go with here. This one itself, you've got a lot of data. So if we were to sketch this, you've got a lot of data at the beginning and then it peters off like that. So we would say it's positively skewed in this kind of scenario, but it doesn't matter. You just want to say for this one, it is skewed. So the data is skewed. So say it's not appropriate. And part F, I'm going to have to go through this bit by bit. So we want to do, we've got A, B, C, and D. So I'm going to go through. So mean and standard deviation. So the mean would decrease. So if you look at this data here, every single class has been reduced by 5. So this has gone down 5, this is 5. So everything else is the same. Everything else is just 5 minutes less. So the mean would be less, and it'd be 5 minutes less. The standard deviation we spoke about earlier today in question 4, I think, but it won't be changed by this idea of shifting the numbers. So this standard deviation is the same. In part B, we found the value of the median. The median itself, so Q2, would be less 5 minutes too, as would all of the quartiles. So quartile 1 and quartile 3 as well. These would both be less 5 minutes. Just use those. Actually, no, let's do it properly. Let's not be lazy. So this would be less 5 minutes. Part C, that was lower quartile. D, we did need to talk about. So D, the interquartile range, sorry. So because Q1 and 3 are both less 5 minutes, imagine what happened here. Instead of it being 25.5, would be 20.5 minus 13.6. Well, this is still 6.9. Your IQR wouldn't change because both numbers are shifted and we're still doing that subtract. So the IQR itself will also be the same. So the two things that remain the same, the standard deviation and the, what am I saying, interquartile range, so measures of spread have stayed the same, but the numbers themselves, the summary statistics for the mean, the quartiles have all shifted by that 5 minutes. So just kind of keeping on top of that. Didn't mean to rub that part out. So this bit here, as I said, would be the same. So that's question 7. Question 8. Question 8, we've got a point. Let's have a look. Just have a quick read of all of this. Okay, so we want to show this normal. So we've been given an equation. We want to show the normal. We're told that the x coordinate is equal to 2. So point A lies on C and has an x coordinate of 2. So right here, we know this is a coordinate of 2. Let's try and find the y value for that straight away. So we're going to put 2 into here. So we've got what y would equal when x is 2 is 20 minus 8 minus 9, which is 9 and 8 make 17. So that's 3. So we know that our point of A is got a coordinate 2, 3. That's going to be important. Obviously, when you're finding any kind of line using y equals mx plus c or y minus y1, the two things you need a gradient and you need a point on the line. So I've just tackled that second issue. We've got my point. I just now need to find a gradient. To find the gradient at when x is 2, we could cheat and use a calculator, which I'll do in a second. But the first thing is we're going to differentiate. So I'm going to take y and I'm going to find dy by dx. So differentiating 20 gives me nothing. Differentiating minus 4x gives me negative 4. And negative 18 over x, remember, is negative 18x to the minus 1. So when you differentiate that, you get plus 18 over x squared. We want to know what happens when x is 2. So this will be a 4 here. So we've got minus 4 plus 18 divided by 4. So we end up with minus 4 plus 4.5, which is simply just a half. This would be the tangent, not the normal. So that implies the normal gradient would be 2 but negative. So it's a negative of that reciprocal. Always the case. So there's our normal. Oh, skipping on. So that's my normal. Then I just want to use y minus y1. But just to show how you get this on your calculator, you can use shift and this d by whatever button. Put in your original equation. So 20 minus 4x minus 18 over x. And then what do you want to evaluate it at? I want to evaluate when x is 2. And it tells me 0.5. So I can skip straight to this line here. I didn't have to do any differentiation myself. A little bit of a cheat. Again, use that as a check, not your actual working. To do the next bit, I'm going to use y minus y1, and my point is 2, 3. So my y value is 3, my x is 2. So I get y minus 3 is equal to minus 2, x minus 2. And then I just want to open all that up. I get y equals, I'm going to add this 3 in a second, but minus 2x minus 2 times minus 2 is a positive 4. Positive 4 plus my 3 is 7. Don't forget, I should have put my x in there as well. And that's what it's asking us to show. Job done. Tick. Part B. The normal to C at A meets C again at the point B as shown. Use algebra to find these coordinates. So not your calculator here. You've got to use algebra. Where 2 points, 2 curves meet, you can use simultaneous equations. So we're going to equate these two equations. We've got minus 2x plus 7 and this thing at the beginning. We know when at B here, they're going to have the same y coordinate. So this coordinate here is going to be exactly the same. So we know that minus 2x plus 7 is going to be equal to 20 minus 4x minus 18 over x. Now leave it like this and rearrange. I personally hate fractions, so the first thing I'm going to do is multiply everything by x. Now you could simplify first if you wanted to, entirely up to you, but I'm going to multiply everything by x. This becomes minus 2x squared plus 7x equals 20x minus 4x squared and then minus 18. So I've actually multiplied every single term by x, not just certain ones, every single term. From here, rearrange set equal to 0. So I'm going to take everything to the left-hand side. So I get 2x squared. 7x minus 20 is minus 13x. And then I've just got this plus 18 equals 0. And at that point, I can, in theory, use my calculator. So this is one way you can get away at this point by using the calculator. So I could put in my 2 minus 13 and my 18. And it'll tell me 9 over 2 and 2. Keep in mind, we've already known the 2 one. It's that other one that we want, the 9 over 2. But you can just kind of factorize this if you want. So we know that we've got 2x and the other one's going to be x. We already know one's 2, so this must be x minus 2. To get 18, this must be a 9, and it must be something like that. So this gives me x is equal to, sorry, this is a minus as well because I want a positive 18. There we go. So x is equal to 9 over 2 or 2, and therefore this is the one that we want. That's not the final answer though, because we need a coordinate. So we need to find my y value. I would stick it back into this equation here. So I want to do minus 2 times 9 over 2, which is minus 9. Minus 9 plus 7 is minus 2. Sorry, just take a deep breath. So there's our final bit. So x is 9/2 and y is -2. That is question 8. Question 9, hopefully a nice fast one. Again, it's a lot of showing, so a lot less calculator use here than what we might hope. Because we've asked to show it, there's a few important points to pull out here. The first bit is when it talks about minimum points. So at the minimum point, we know that dy by dx is equal to 0. So that's really important. So dy by dx equals 0. That's at a min or a max turning point. So we basically want to differentiate this and say equal to 0. So differentiating this, we get 6x² minus 34x plus 40. And we want to know when is that equal to 0. So we can use our calculator for this one, not a problem. So polynomial degree 2, we know it's 6 minus 34, actually put 6 minus 34 and 40. So that's going to tell me it's at 4 5/3. So x is 4 or 5/3. Now, use logic here. We've got 2 turning points here and here. This one's clearly the one that's further along the x-axis. So that's going to be the one that is 4 because 5/3 is less than 4. Job done. So we know that k equals 4. So when we come to actually integrate this and find the area, we want to integrate between 0 up to k. So that's the area we want. So it sketches that out. So 0 up to 4 of y. I'm going to write this out in full this time. So when we actually integrate this one, which we are told we've got to show, we have actually got to do it. We're not allowed to do it on graphic calculators or whatever else. So integrating this, we get, integrating this one, we get 4. 2 divided by 4 is a half. So we get x to the 4 over 2. This one's going to become a 3. So it's minus 17x³ over 3. And then last bit, this is a squared. So it's just going to be 20x². And we're going to do that between 0 and 4. So all we need to do is stick in some numbers. 4 times 4 times 4 times 4 is 256. And we want to divide that by 2. But ultimately what you want to do is just show that you know what you're doing here. So I'm going to substitute my 4 in, divide it by 2, substitute my 4 in, divide it by 3, and substitute my 4 in to this one. When you substitute your no, divide on that last little bit. When you substitute in it for 0, big thing to note is that everything's going to be 0. So I'm just going to put that at the end there. So let's just put in ants to the power of 4 divided by 2 minus 17 ants cubed. And again, I want to divide that by 3. And lastly, plus 20 ants squared. And that gives me 256 over 3. So that's it, 7 points in the bag, question 9. Question 10, final bit here as we go through. So let's have a quick look at what's going on for question 10 and then try and figure out how to go about this. So the first bit is a show that. So we want to kind of get, oh, there's a lot of letters on this one. The most confusing thing on this is the amount of letters. We've got A, B, C, D, E, and F. So it's made up of half a circle. We've got a rectangle. We've got an equilateral triangle. We know this is X. So that means that this bit here is X, which means this is X. So that's the diameter of my circle. This, therefore, is also X. So I just want to try and figure out what's going on here. It tells me that the area of this pool is 50. So I know the area equals 50. Maybe I need to come up with something to do with that in a second. Given that, show that, okay. Okay. So let's find the area. So we want to find the area of this bit, and this bit. So that's the first thing. So I'm going to do that one by one. So for number 1, I know it's equilateral, so I'm going to use the area of a triangle is half AB sine C, because I know an equilateral triangle has a 60-degree angle up the top here. So I'm going to do 1/2 times x times sine 60. And I know this is x² times root 3 over 2. So this will be x squared times root 3 over 2, all divided by 2, which is over 4 in the end. So that's the first little bit. Number 2, rectangle, easy, xy, job done. Number 3, half a circle. So I've got pi r squared divided by 2. So the radius itself is x over 2. So this would become pi times x over 2 squared, then divided by 2, which is x squared over 4, and then over 2. So that's going to be x squared pi over 8. I think, yep, that all looks good. So, and all of that, when you sum it together, is going to be 50. So nice. So I know that when I add all these together, I get 50, and I want to know what y is. So xy equal. So let's not go straight into that. Let's add them. So xy plus x squared root 3 over 4 plus x squared pi over 8. That's all equal to 50. Let's see what we can do here. So let's take it all away first, apart from the xy. So we've got xy equals 50 minus x squared root 3 over 4 minus x squared pi over 8. And then we're going to divide everything by x in just a second. Let's simplify this up, because if you notice in the question, there's some factorizing. Let's do some factorizing here. So we'll take an x over 8. Actually, I'm going to take an x squared over 8. So I've got 50, and then a minus x squared over 8. I'm going to open a bracket. Because I've taken a minus out, these will both become positive. X squared's gone. Because I'm taking an 8, though, that's going to put a 2 root 3 here. Because when you times these together, the 2 and the 8 will become back to the 4, plus pi. So that's if I factorize, which looks something like what they've got. Now, the last thing is to divide everything by x. So that was xy. So y is therefore equal to this 50 over x minus x squared over x is just x. And then that's then left as it is. So that's part A. A lot to do for simply 3 points, but that's A. I am going to clear that off just so I can continue. So part A, there's a lot going on there. I've written a lot more than I usually would for that, though. Apologies if you're going to scratch my kind of pen here. I've written a lot more than what I usually would for that. But it is like back-end question, a little bit harder. There we go. Okay, so part B, now we've got that, it's talking about perimeter, and it says, hence show the perimeter P is given by whatever value it is. So let's actually come up with a normal thing for the perimeter here. So the perimeter would be x plus y plus whatever that is, plus y plus x. I've got 2 x's, I've got 2 y's, and then I've got whatever half the circumference is. So circumference is pi times d, half of that is half pi d, where my d is x. So I've got a half pi, and then my d is x in this case. So all I want to do is replace what y is. So I'm just sticking y into there, and hopefully I'll get this thing. So a lot of algebra. So p equals 2x plus half pi x plus 2 lots of, and then I've got this 50 over x minus x over 8 pi plus 2/3. And I just want to multiply all of that out. So very quickly multiplying that out and then trying to factorize what I can. So a lot of this is just rewriting terms that I've already had and then cancelling. So here I've got 100 over x, not a problem. Here the 2 and the 8 will cancel to give me a quarter. So I've got minus x over 4. And then I've got that times by pi. So I'm going to do that. And then I've got this minus x over 4 times this thing. So that's going to become a minus x over 2 root 3. So that's the kind of all expanded there as well. And now I want to bring it all together. So the 100 over x stays separate, but we have got some x's and all the kind of bits going on here. So what we want to do is try and gather all that together, which isn't too great really, is it? Let's have a quick look, see what we can do. Bum, bum. So I'm just having a look to see what I can actually add up and what I can't add up here. So I've got, I'm going to use my calculator just to show you some of this. I've got 2 x's and I've got a root 3 and a minus root 3 over 2. So if I did 2 minus root 3 over 2, it gives me this 4 minus root 3 over 2. If I then divided that by 4, I suppose. Do I want to divide by 4? Probably not, actually. Let's just go back and keep it that for now. So I just want to try and simplify things. So that's my x coefficient here. So I've got, if I bring this together, that's my x's. So I've got 4 minus root 3 over 2. That's my x coefficient. My pi coefficient, so my pi x's here, I've got a half pi x and a quarter pi x. So I've got 1/2 minus 1/4 effectively, which is just a quarter. So these two here give me plus 1/4 pi x. And then lastly, I've got that 100 over x, which is just separate. So that's a positive. And then I want to try and factorize out. And in the question, they've taken out x over 4 just from these two terms. So that's what I'm going to try and do here. So p equals 100 over x plus, and then I'm going to take out x over 4. So if I take x out of here, I get 4 minus root 3 over 2. However, if I take 4 out, I need to times everything here by 2. So that will give me 2 times 4 is 8, and 2 times root 3 is 2 root 3. So that's the first little bit. That's this one factorized. This one, if I take x over 4, I'm just left with pi. And that's what they want in that question. So that's part B. It's a lot of algebra kind of stuff. In part C, use calculus to find the minimum value of p, giving your answer to 3 significant figures. So we want to differentiate this. So differentiating p, getting p dash. Differentiating this one gives me, so remember this is x to the minus 1. So I get minus 100 over x squared. Differentiating this one a little bit weirder here because the coefficient is actually this over 4. So plus I get 8 minus 2 root 3 plus pi, and all of that is then over 4. So my x just disappears there. So it's quite a nice one to differentiate. Because we're trying to find a minimum value, it's when this equals 0, and I just want to solve that. So what I'll do here is I'll times everything by x squared. So it'll disappear from down here, but it'll appear up here. And then I'm going to take the 100 across. So I get 8 minus 2 root 3 plus pi over 4. X squared is equal to 100. Then I can times up by my 4 to get 400, and then divide by this absolute load of nonsense there to get what x squared is. So x squared equals, on my calculator, 400 over 8 minus 2 root 3 plus pi. Fantastic. What a great answer. So x squared is 52.100 ... So x, therefore, is the square root of that answer. So x equals 7.218 ... That is just what x is when this is a minimum. I want to know what p is. So I need to take the answer and I need to put it back into the even more ridiculous equation that was up here. So now p equals, on my calculator, I'm going to do this again just with the ans, just because I know, well, I know it's going to be a little bit easier for me rather than writing out that number. Everything else I'm just keeping exactly the same as it was. I just need to press equals. So I get 27.7. And that's part C, isn't it? Yeah, so 27.7. And it wants it to 3 significant figures. So 3SF, that's what I've got there. Units here, because it's in meters and we're looking at a perimeter, it's simply just meters. So I should, I suppose, put somewhere meters. I don't think I'll be punished for that. Part D, justify by further differentiation that the value you've got is a minimum. I'm going to squeeze that over here. So I want to do P double dash. If I differentiate this again, it's an x to the minus 2. So it will become here 200 over x cubed. And I want to find out what value of that, or what that value is when x was 7.218. So if I put that into there, so when x equals 7.218, p double dash is equal to, let's just go strip all that back to when I square rooted the answer. So that's just this bit here. So I'm just going to put in here 200 divided by ans cubed. That gives me 0.5 blah, 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 which is actually positive. So therefore it is a minimum. So p double dash is 0.53, which is greater than 0, which implies it is a min. And that's all I'm looking for at the end there. So a lot of stuff going on in that last question, but I hope that helps. Thank you very much for watching, guys. As I say, all of the timestamps hopefully will be at the bottom of here, so you can flick through at any point. But thank you very much. If you need any more questions, just let me know, either in comments or wherever else you can find me. But just let me know. Thank you.